Okay. So now this is a general thing. This is something you need to be able to do in general. We use it almost in all questions. Let's now just look at some specific things, and I'm going to do it in order, even though it's not necessarily the order that they used in this exam that's passed, but this is usually the order in which the question is asked. The first is angles on a Cartesian plane. Okay, now Cartesian. I don't remember if that's how you spell it. Okay. It doesn't really matter. There's different ways in which they ask it. Basically, what they usually do is they give you a ratio and an interval. Now, if I say a ratio, I mean something like tan theta is equal to 5/7. Or they maybe don't give it so easy like that. They might say something like 2 sine x is equal to 1. Okay, and you have to convert it into a ratio. But nevertheless, they usually give you some sort of way to find a ratio, and then they give you an interval. And with the information they give you, and sometimes it can be something like sine squared theta is equal to p. Okay, the point being is that your first step in this way, let me first describe the whole question. They give you that, and they give you an interval, and then they ask you to find, and they might give you 1 or 2 or a number of expressions that you have to find either as a value or in terms of p, or in terms of whatever they've given you. Okay, so they'll give you expressions here. Now, in this, it's important that you go and draw a sketch. I know you guys know how to do this. Okay, it's one of the simpler things supposed to be. So let's look at a simple example. Let's take this first one. Tan theta is 5/7, and then they give you usually an interval that spans over 2 quadrants, I mean. So let's say from -180 to 180. Okay? So we know from -180, no, that's not 2, that's only 1. Let's say from 0 to 180. So somewhere along here, okay, one of those 2 quadrants. But then we also see tan theta is equal to 5/7. Now we can see that means tan theta is positive, which means it must then be in the first quadrant. So we'll draw a triangle in the first quadrant. We know that tan theta is opposite over adjacent. So again, that's probably the most fundamental. I just assume you guys know that. Tan theta, opposite over adjacent. Sine theta, opposite over hypotenuse. Cos theta. Excellent. If you know that, guys, I promise you, and if you simply apply that in a basic way, you can usually answer most questions. Opposite over adjacent, so that's 5/7. And now all we need to do is find the hypotenuse. 5 squared plus 7 squared gives me 49, 25 is 50, 74. 74. So this is the square root of 74. And now they can ask me anything. All I'll need to do, and remember that this is now theta, they can ask me anything. They can ask me something like cos theta, and all I'll now do is read off from my graph. So cos theta, I'll read off is 7 over square root of 74. Okay, let's say they give me something complicated like sine of 180 degrees minus theta. Okay, so reduction formula comes in here, and I need to know that sine of 180 minus theta is in this second quadrant. Okay, so in other words, this angle in here, I know theta itself is in the first quadrant. So 180 minus theta will be in the second quadrant. So this must be a negative answer if I change it to sine, a positive answer. If I change it to sine theta, And now I just put sine theta is opposite over adjacent, over hypotenuse. That's the answer. Everything okay so far? And now let's say something like cos of, let's go for theta plus 60 degrees. How would we do that one?
Won't we expand it to cos theta?
Cos theta.
Cos 60.
Cos 60.
Minus sine theta sine 60.
Excellent.
And because cos 60 and sine 60 are, what do you call them?
Special.
Yes, special angles. We'll substitute the actual amount of cos 60 and sine 60.
Excellent.
And then we can, from the graph, deduce what cos theta and sine theta is.
Good. So cos theta and sine theta we can get from the graph. So in other words, cos theta is 7 over square root of 74. I'm not going to reteach what the special angles are. You guys know them by now, ne? What's this one?
Isn't it square root of 3 over 2?
It is. Pendila knows. Okay, minus sine of, no, sorry, it is not. Cos of 60 is a half. Okay, sine of 60 is, this one is 5 over square root 74. Sine of 60 is square root 3 over 2. Okay, again guys, that's one of those things that, okay, you can use your little diagram to go and figure out that special angles. Do you guys know this diagram? Not? Then you've definitely not been watching the videos, huh? Okay, not going to reteach it. So to simplify this, okay guys, remember we should have same denominators. 7, they'll probably tell you you're not allowed to use your calculators. So if after this you just give the answer, you'll get 0. Because you've used your calculator. Okay, so I already have same denominators. 2 square root 74 over 7 minus 5 square root 3. And then usually we should not leave a surd in our denominator, so we'll just multiply top and bottom with this. And so in the top I now get 774. I wonder if 74's half is 37. No, so this one can't simplify. Minus and then these two multiplied together gives me 5. 74 times 3 is 232 over, and these two cancel, the square roots times 2, so this is all over 2 times 74 is 148. Okay. Questions?
What do you mean by when you ask us to solve in terms of P?
Okay, so let's do an example. Let me just see if there's a question on the question paper. Yeah, there's one on the question paper. Okay, so here they give you, let's look at that one. So they give you sine of 54 degrees is equal to P. And they ask you to find sine, cos of 18. Cos of 18 degrees in terms of P. Well, there's probably different ways of doing it, but you could just draw this graph. Okay, for sine of 54, that means this angle is 54, and then since it's just P, we should put it P over 1. So our opposite is P, our hypotenuse is 1, and then if we use Pythagoras, we can find this side length as 1 minus P squared. Square root of 1 minus P squared. Everyone okay with that? And there I've got a triangle. So now depending on what they ask me, I can use this triangle. I could just maybe get this other angle here. This is angle 36. Now, after I've got this, I go and look at the question that they ask me. Now I see, okay, cos 18. It has nothing to do directly with this triangle. You notice that? Okay, but what we could do is we could say, okay, but cos of 18 is I could rather take this sine 54 and I could say, well, I could rather say that cos of 36 degrees is equal to, and then now the cos of 36 is opposite, sorry, cos of 36 is adjacent. So there's the 36, here's cos is adjacent over hypotenuse, so that's also P over 1. And I could see, okay, but cos of 36 can be written as 2 cos squared 18 minus 1. You guys see where I get, how I get from here to there? Pendile, you see, ne? Olivia, do you see? Buso, do you see? You don't see. You please stop me. If you don't see, then there's other people that don't see either. Okay, so cos of 36 is cos of 2 times 18. And this is the double angle formula. So this is like saying 2 times theta, but instead of a theta, I have 18. So instead of saying this is 2 cos squared theta, I say it's 2 cos squared 18 minus 1. And this all should be equal to P, because cos of 36 is just being replaced with this expression. And so now I just solve for cos squared 18 is equal to P plus 1. Divide both sides with the 2. I'm doing BODMAS backwards. Okay. So then I divide everything with a 2. You still with me? And then finally I say cos, I take a square root on both sides to get rid of the square, and that's when I get the square root of P plus 1 over 2. And technically I should put the plus minus, technically, because I took a square root on both sides, isn't it? Why don't I have to?
Isn't it? Okay, no. Wait, isn't it because of the interval they gave us?
They didn't give us an interval in this question. They didn't have to, because we know what the angle is.
Because cos is positive from the get-go.
Sorry? No, say it loud. You're right. I just didn't hear you.
Isn't it because cos is positive?
Why is it positive? Because it's not always positive.
Yes. Because
Yeah, say it loud.
because 18 puts you in the first quadrant.
Yeah, exactly right. 18 puts you in the first quadrant. Cos is positive in that quadrant. If this was something like 118, then I would have taken plus minus, but I would have taken the negative, because 118 puts me in the second quadrant, and cos in that quadrant must be negative. Does that make sense? Okay. Does it answer your question? How to answer things in terms of P? It's not, this is actually a complicated one. They're not always that complicated, but it always comes down to converting the expression that they give you, or to answer, or the one that they originally give you, to convert it into the other one that they gave you somehow.
The fact that you actually recognize that it's a double angle actually helps.
It didn't help, it's what you had to do. so yes, so you have to be able to recognize double angles. If you don't, that's really why I think people did terribly in this in this test. They don't know their identities. Okay. Okay, guys, I'm not going to go through all of the work, of course. Okay, I just quickly want to show you the second part. So the first one, the most important general thing is to know your identities. Second one is to know how to convert a given ratio into a triangle, and then use that triangle to answer given questions. The second thing that they usually ask in a question, and you'll notice in this exam, they actually gave you, oh, actually here's another one that we can do here. Let's try that one first. So they give us 13 cos A equals to 12. So they give us 13 cos A equals to 12. They also tell us that A plus B is equal to 90 degrees. Okay? And then they ask us to find sine A minus B. So your first mark, okay, this is 6 marks, but your first mark went for, this is what they ask you for. So what do you think the first mark went to?
Expanding.
No, expanding it. What should this be? No, stop looking at your formulas.
Sorry, I'm expanding it.
It doesn't matter, what did I call it? Same sign, different ratio. Just follow that.
Sine.
So what should this be?
Sine A.
Yeah.
Cos B.
Sine A?
Cos B.
C, you didn't need to look. And?
Plus. No,
Plus.
same.
Same, yeah.
Minus. Sine B. Then cos A.
Cos A, look at that. See, when you guys, I promise you, when you rely on something else other than your mind, you're not learning. It's really, you're cheating basically. Okay. Okay.
Does it make a difference if I have the sine, if I have the cos A first and then sine?
In the term you can write cos B sine A or whatever, but in your expression, this it must be first a sine and a sine A and a cos B. So it has to be sine A cos B. You can't start with sine B cos A or cos B sine A. So in both of them, even if it was the cos, you'll see when you start with cos, my suggestion, if you have sine, just start with sine. If you have cos, just start with cos. Okay, and then keep your AB in the same order here as well. It doesn't make a difference when this one is a positive one, but when it's a negative, it does make a difference. Okay, so that was what your first value went for. Now notice that once again they gave us a ratio, and they didn't give us an interval, but they gave us something else that's interesting. So let's just go and draw. Did they give us an interval? No. Okay. So we'll just draw a triangle. Then it doesn't matter. If they didn't give you an interval, it doesn't matter where it is in the Cartesian plane. Okay? But they tell us that cos A is equal to 13 cos A. So obviously we have to change this into cos A is equal to 12 over 13. So adjacent is 12, hypotenuse is 13, and if you use Pythagoras, you'll see that one is 5. I'm not going to go through the calculations, but you guys know how to do that. Now once you have this, what is this angle?
Cos A.
It's not cos A,
No.
it's just A.
A.
This is angle A. Cos is then the ratio of the adjacent. Okay, what would this angle be? What? The angle.
Isn't it B?
Why is it B?
Because that one is 90 degrees.
This one is 90.
Yes.
So these two together must be what?
90, so that the triangle can be put to 180.
Exactly, and it tells me that A plus B is 90. So this is B. Can you understand why they gave you this? So what you could have, guys, what you know, this angle here is always 90 degrees minus that angle there. Always. So even if you didn't know it was B, you should have written it as that. Okay. And that would have also been fine, because look what happens now is if you use this, you could have changed everything into A by just saying, well, each time I have a B, it should be 90 degrees minus A. So you could have said, well, this is the same as sine of A cos of 90 minus A minus sine of B cos, sine of 90 degrees minus A cos of A. And now what is 90 minus?
The sine.
For cos it's a sine, for a sine it's a cos. So sine A minus sine cos, sorry, thanks, cos A cos A. What is this actually? This is sine squared A minus cos squared A. What is this actually? Okay? Yeah, double angle identity. It's sine 2A. Actually, so why is this sine 2A? Because if I, from the beginning, I changed B to be sine A minus, so there were many different ways of doing this question. If from the beginning you changed B to be 90 degrees minus A, you would have gotten sine, oh, this is not sine, sorry, this is cos. This one. It's actually minus cos. Okay, because cos is cos squared minus sine squared, and this is sine squared minus cos squared, so it's negative cos. So notice here, what happens is this becomes negative 90 in here, and positive A, so this is negative 90 degrees plus A. Where is plus 2A, because there's an A in A, 2A. So where is, so whenever there's a 90 inside, where is that on the quadrants? This is a negative 90, plus would be in this quadrant. Sine in this quadrant is negative, so this is negative, and since there's a 90, I'm using one of the vertical axes, I use my co-ratio, so sine changes into cos of 2A. Okay, so nevertheless, I'm actually maybe confusing you with showing you the different methods before I take one method to the end. But still, in the end, I have to get sine squared A minus cos squared A. And here's A. Sine is opposite over hypotenuse. So 5 over 13 squared. Sine squared A is 5 over 13 squared. Minus cos squared A is adjacent. 12 over 13. They actually gave me cos in the beginning, 12 over 13 squared. So in the end, this is 25 minus 144 over 169. So my final answer is negative 1195. I think so. Notice I get a negative answer. That's also what I suspect, that my answer in the end has to be negative.